some kind of exposure to remote sensing, GIS, GPS. But still, just to keep everybody onto the same page, I have kept some of the slides which are very basic so that we all understand it in the same language. And more than biomass and carbon, I give you slightly better taste of how remote sensing GIS could be used in forest management and forestry kind of applications. And then we will conclude. And I will see that I don't, go beyond 5 o'clock. I will finish it as early as possible. And so that if at all you have any questions, so आप लोग वो भी पूछ सकते हैं. So this is something very basic. When Sharma ji was talking in the introductory session, so he mentioned about sustainable development. And now, if you see, sustainable has actually become a very big word. In the sense, it is prefixed to everything which we are doing. Everybody talks about sustainable agriculture, sustainable forest management. So essentially, the way Brundtland talked about, you should have 3 pillars: social, ecological, and economic over there. And many a times in the democracy like ours, so most of the time, these kind of all responsibilities, they rest on the government or say forest officials. So I, as an academician, I see forest officers are not only resourceful, not only knowledgeable, but sharing the responsibility of bringing sustainability in all their activities. So obviously, when you do these kind of things, आपके अपने सवाल होंगे कि कैसे हम इन चीज़ों को इस्तेमाल कर सकते हैं. So वो कहीं ना कहीं management question में reflect करता है. So for academician like me, it becomes more of a research question. And over the period, the way I have tried understanding ecosystems or landscapes or say any kind of resource including forest, so मुझे ये समझ आता है कि remote sensing GIS का कुछ benefit है than that of conventional techniques. It could be efficiency, it could be effectiveness, and if it could be also exemplary. ताकि आप एक जगह उसको use करें तो you feel like using it in many areas. When I come to forest specifically, so we get to understand there are wonderful resources which we have and which could be very nicely digitized or digitalized for better understanding or for better management of resources. One comes from Survey of India topographic sheet. Even on date, most of us, we rely, and especially when I come to state forest departments and all, that is over there. But remote sensing actually started with Remote Sensing Center, National Remote Sensing Agency, which is now called as National Remote Sensing Center. And it has tried mapping forest cover, and that was probably the first attempt where forest cover was mapped. And then subsequently we get to see Forest Survey of India came into existence, and it has taken a lead in forest resource mapping and specifically forest cover mapping. And the recent report 2021 which has come, it has made a lot of noise. We ecologists, academicians, we generally are very critical about when you speak of forest per se. So we'll talk about that also. In addition to this, there are many of the data sets which are available with Forest Survey of India at the behest of aerial photography, which is again there. And probably somewhere we committed कि after every 10 years we'll be doing it, thanks to high resolution remote sensing. अभी हम लोग देखते हैं कि there are many good tools to make it. Apart from that, you all are into working plan kind of stuff, So just you get to create lot of database, including forest stock map, and then other kind of data sets. So when we talk about remote sensing here, it is an art of collecting information about any process, phenomena, or object without in physical contact. The beauty is this, which we call as spectral signature. And this is unique, and that helps me to create an image which is helping me actually to decipher among the features. So these all things come in different wavelengths of electromagnetic radiations, and those are collected in such a way that they could be seen as individual images, or those could be formed as a composite. Like what you see over there, that is true color composite and false color composite. So for a common person, layman, Google Earth, you get to see everything as a true color composite. But for somebody who is actually interested in a scientific study, so most of the time we try to see things in false color composite. So the basics are very clear. Like if you look at this graph over here, You will get to see the information between 0.4 to 0.7 is which you are able to see with your naked eyes. Whereas when remote sensing comes, in addition to visible spectra, you are able to collect information in other wavelengths also. We generally call it near infrared, middle infrared, short wave infrared, microwave, thermal infrared, and all. Now, if you concentrate on this graph particularly, you will get to understand that 0.7 onwards, where near infrared is, आपका जो spectral response pattern जो है, वो unique है. You can always argue कि 0.4 और 0.7 के बीच में भी unique है, लेकिन वो uniqueness इतनी अच्छी नहीं है कि आप चीज़ों को differentiate कर सकें. 0.7 onwards जैसे ही आप डेटा देखते हैं, so आपकी differentiation capability बढ़ जाती है. और शायद यही रीज़न है कि रिमोट सेंसिंग नियर इंफ्रारेड फोटोग्राफी भी बोलते हैं लोग, और नियर इंफ्रारेड डोमेन में पीपल जनरली ट्राई टू कलेक्ट इंफॉर्मेशन. Now when you look at this, so what we have done is we have information which is captured in near infrared band, red band and green band displayed on red image plane, green image plane and blue image plane. So, jo picture tube, image planes, color guns, these are the terms which are used in computers. Or as a result, what you are seeing, that is called as false color composite. The moment I use, red on red, green on green and blue on blue, you get to see something called as true color composite. So, जैसे ही मैं इन दोनों के बीच में compare करने की कोशिश करता हूँ, false color composite और true color composite में, so मुझे I get to see कि the information content is more in false color composite than that of what is there in true color composite. अगर आप सिर्फ lawn को ध्यान से देखें, so आपको false color composite में जो gaps हैं, वो बहुत prominent दिखाई देते हैं. जैसे ही आप tree cover area को देखें, तो आपको false color composite में differentiation और ज़्यादा मिलता है than that of your true color composite. And this is why people are using false color composite for many of the things. दूसरी beauty इसमें यह है कि when you have a satellite, in the same satellite, you can have multiple sensors. In the sense, a sensor which is looking at entire Earth or part of Earth or further refined part of the Earth. It means at the same time, you are able to see things at multiple scales. You are able to see at multiple scales, and those all are for the same season, same geographical area, the degree of details are changing. So उसको generally हम लोग special resolution बोलते हैं. So you have a data of a special resolution of 1 kilometer, 500 meter, 200 meter, maybe say 50 meters, 30 meters, 25 meters. So that way you get to see many details. और आज की date में best special resolution is 25 centimeters. So it means things which are of a dimension of 25 centimeters by 25 centimeters, and if there is a cluster of object, you should be able to detect it very nicely. दूसरा इसमें beauty ये है कि if you look at these images, earlier was December, this is January, then I am coming to February, then I am coming to March, and then I am coming to April. So as I keep changing the months, you get to see some variation which is happening on the ground. And typically, the landscape which we are in, where dry deciduous forest is dominating. So we'll get to see seasonally these all kind of things actually vary. So any kind of natural change, I would say even any kind of natural change is there. So आप लोग उसको satellite data में बहुत बढ़िया ढंग से capture कर सकते हैं. और जैसे ही it comes towards leaf condition, so again you will get to see redness. So even the seasonal changes, one is able to capture those. This was all about remote sensing. Another thing is GIS, Geographical Information System. Anything and everything which is around, जो भी चीज़ आप किसी भी तरह का डेटा आप यूज़ करें, तो उसको हम उसके latitude longitude से जान सकते हैं, उसकी पोजीशन से. और GIS is all about this. It is like any other information system जहाँ पे आप computers maintain करते हैं, Excel, DBase और Oracle, किसी भी तरह का database, लेकिन ये special data को भी साथ में रख रहा है, along with non-special data. So कोई भी information आप use करते हैं, उसको with respect to उसकी location it is able to capture. And everything and anything which you are able to differentiate with respect to nature. Like say I talk about road, Mahatma Gandhi Road, Bahadur Shah Safar Road, Abdul Kalam Road, names. Double lane, triple lane, single lane, metal road, unmetal road, you name it, any kind of characterization you do, you can save it as a separate layer. So that is beauty with GIS. The way you think, it can convert your thought process as one of the layers. And then you bring those layers on the top of each other, and you are able to bring out many newer kind of information. Now, you have resolution, you have scale, and you have data type. These all things are dependent with scale. How big area you are looking at a division, range, beat, or a particular plot. So the degree of details are changing. But you are talking about your district. So these all data sets, they all talk to each other with respect to location. और beauty ये है कि आप किसी भी स्केल में डेटा कलेक्ट करते हैं, आप उसको अप स्केल भी कर सकते हैं और डाउन स्केल भी कर सकते हैं. इसका मतलब अगर कोई बहुत लोकल लेवल में आप इनिशिएटिव ले रहे हैं and somebody is doing at national level or global level, those data sets are able to talk to each other with respect to their location. So the variety of sensors which we have with respect to spatial resolution and all, I am able to play with those. So this is all about GIS. Then the another technology comes, that is GPS. That is a simple instrument where you have constellation of satellites around the earth, which started with United States. वो डिपार्टमेंट ऑफ डिफेंस के लिए उन्होंने बनाया और फिर ग्रेजुअली लोगों ने देखा कि इट इज समथिंग वेरी गुड. क्लिंटन वाज द प्रेसिडेंट, ही सेड इट शुड बी यूज्ड फॉर द सिविल पर्पसेस आल्सो. देन मेनी ऑफ द कंट्रीज लाइक इंडिया, जापान, चाइना, एंटायर यूरोपियन यूनियन, रशिया, दे ऑल थॉट कि वी शुड हैव आवर ओन सेट ऑफ जीपीएस सैटेलाइट्स. सो टुडे द स्टोरी which started with 24 satellites roughly, today you get to see hundreds of GPS satellites which are moving around. And you are simply connected with an instrument which is as small as your mobile phone. And you simply, switch it on, it connects with those, and it tells you your location precisely, and also your altitude with respect to mean sea level. You go for a morning walk with your mobile, you are able to put your, track on your Facebook. Same thing it also does for you. आप वो GPS को लेके, you make a person to run around any boundary, or it is able to create a boundary map for you, which can come in GIS, and which could be validated through your remote sensing. So it means these three distinct technologies. Generally, people feel remote sensing, GIS, everything is one. These all are distinct technologies, distinct sciences for me. You can integrate these all together and find out much better answers for any kind of question. When I talk to my students, I generally say remote sensing without sensing is non-sensing. I simply can't say कि मेरे पास satellite data है और मेरे पास अच्छा processing speed है and I can do everything. Unless I get down onto the ground, I talk to the people who are actually engaged with that resource. So many of times we have seen that it gives you it miscommunicates you. So that is something we call error. There are many sources of errors which come in your remote sensing data processing, GIS analysis, and even GPS data integration. So you need to carry out something called as ground truthing, which is must. The only difference is earlier probably you were going to 100 locations. आज की तारीख में क्योंकि आपके पास remote sensing data है, क्योंकि आपके पास GPS है, आप 25 लोकेशन में भी जाएंगे तो शायद आपका काम हो जाएगा. So that kind of shift is there, but it will never be able to replace ground knowledge. And here, forest managers or the resources which are there in the forest department, that is of value to us. Because you know the ground better. I can say many things about your area, but ground में क्या हो रहा है, उसको अगर मैंने connect करना है, so मुझे ground truth की बहुत ज़रूरत पड़ती है. So for quite a good time, if you see how remote sensing has come into forestry sector, you will get to understand that people were more relying on this kind of map, which was prepared during British times. And then at some point of time, only 6 scientists, given a time frame of 6 months, could map forest cover for entire country and tell us that forest is not 40%, it is much lesser than 20%. And that is how remote sensing has actually come into picture. And then people tried, looking at it further. And today we get to see that probably India is the only country which is able to map its forest cover after every 2 years. And we get a very beautiful report which gives you information which is very good at pan-India level, which is very good at state level, even up to district level, that gives you a wonderful statistics. And if you catch hold of the database which is there with FSI, so you will be able to go up to, taluk level or say sub-administrative level also, and that is something good. There is a lot of criticism which is attached with that report, that again stands true. But that doesn't determine the importance of such kind of initiative. This is which you all should be proud of, and actually I feel very proud of using such type of technology. What these guys are actually doing, they have satellite data for different time frames, and if there is any change which is taking place, it is getting converted from red to cyan. You know, it will jet red, reddish, dull red, and probably tinge of green or blue, and then cyan. And I say that forest is going. There is degradation, there is deforestation, which is taking place. And that is getting converted into density. You say, I have a very dense forest, more than 70%. You say, I have moderately dense forest, 40 to 70%. And what the difference is? The degree of redness. And the moment you come to the level of scrub or non-forest, it becomes something like this cyan. And you say, there is no more forest. So these indicators, visual interpretation keys are being used. These digital numbers are being used to map the forest cover. And we get to see there are a lot of, deforestation, degradation, which has happened in past. Like what you see over here, this is a comparison between 1970s and somewhere of 2010 or 2014. And see the drastic, contrasting change which has taken place. And these are not two-season data. This is the same season data, and it is able to tell me that lot of forest is getting converted into non-forest. It is not always true. There are some of the examples wherein forest is coming back, like the state which I represent, Uttarakhand. I get to see on the ground, I get to see on the satellite data, and many of the reportings which are coming, wherein a lot of abandoned land is getting rejuvenated, and some kind of trees are coming over there, and forest might come to a shape which we all call as forest. So it means there is a whole range of opportunity which is there in many of the landscapes in the country. So what actually the science is, you have satellite data which needs a degree of pre-processing. We generally call it geometric correction and radiometric correction, in the sense I want to know location with respect to coordinates. A pixel which I see, the moment I click, it should be able to tell me which location I am talking about. So that is geometry. I am aligning it with the geometry of map, cartography. The second thing is radiometric correction. There could be many atmospheric, each love story has a villain. So in the love story of remote sensing, these clouds, haze, atmosphere, that comes as a villain. So we need to eradicate that. So we do it very silently. We call it radiometric correction or atmospheric correction. Once that is done, you know what is your first love. That tree you know very clearly, and you know the location of that. And then I come to something called as enhancement. Can I see it in much better way? Can I differentiate it with respective surrounding? Because it is all mosaic. And once I know that, I can do lot of things in enhancing that. And then the best way of doing it is visual interpretation. I say it very responsibly. If your area is very small, and if you have a very good control on your area, so visual interpretation is something very good. And using some ancillary information, which I call ground truth, legacy data, I prepare a map. But before calling it as my final map, I do something cross-checking. So people say, what degree of uncertainty is there, or what kind of accuracy is there in your mapping? Is it 80% correct, 90% correct? That kind of thing we generally say. If you read the foreword or preface of Forest Survey of India report, somewhere at the bottom, they spell it out very categorically. They say the accuracy ranges between 86 to 92%, that kind of thing. Everybody should tell, honestly. So that is what most of the time things are attempted for. So once my database is ready, it means I have a very good knowledge about my area. Then what I do, I take time to data, I put the same vector on the top of that, wheresoever changes have taken place, I simply delineate it. You see my high school photograph and photograph of today, you will be able to see changes. Many heads are telling me that, there are pretty decent changes which have taken place over the time. Same thing is being done over here. You simply look at the variations which have come. It could be positive, very rarely with our heads, but it is negative many a times when you are looking at such type of changes which are over there. So you are updating your map. So this is how you keep on creating database. So it means FSI has a capability to do it every next year. So that kind of capability should be there. And what exactly is happening? Your canopies are actually changing like this. This is how I have been taught about forest density. अगर आपको canopy density देखनी है, you just stand there, you see a broader area, and then you try to see how much sky you are able to see. I am able to see 90% of tree cover, only 10% of the sky. And subsequently, my green cover is decreasing. And the same impression is coming on my satellite data. And I am able to pick those kind of changes from there. But this is all visual interpretation. Your computers are very intelligent. You train them with some sample. You say, अगर आपको ऐसा पिक्सल मिले तो ये dense forest है. अगर आपको ऐसा पिक्सल मिले ये non forest है, scrub है. You give some samples, some training sets to your computer, and your computer will be able to quickly give you the density map. And that is how FSI is able to do it very quickly nowadays. It is using the digital platform. It is using the computers to do it. And accuracies generally vary. Accuracies can depend on the landscape. आप यही चीज नॉर्थ ईस्ट इंडिया में कीजिए, it is a very rugged terrain, very tough terrain. Lot of challenges of shadow, lot of challenges of shifting cultivation, secondary growth, gone. You go to Karnataka, maybe lantana will play a very important role over there to say I am all green, but it is not. But if you come to central India and all, maybe because of the flatter landscape, you are able to take the advantage of terrain and those kind of things. So accuracy will vary, but still you are able to make these kind of density classes. And our academic exercises actually tell us we can generate density classes at the interval of 10%. 20% is very convenient. FSI need to look at those kind of approaches and adapt that knowledge so that it can further disintegrate the 3 density classes into probably 5 density classes. This is one of the criticism which comes. Earlier there were only 2 density classes. So people were not at all happy. More than 40 means anything. You are second divisor, you are first division, or you are a distinction holder. I come from that age, so I can use that example very much. So everybody is same. So those kind of variations were actually there. The other thing comes type. Density is good, but type is very important. तो जब भी हम लोग type की बात करते हैं, तो हमें ground में और ज़्यादा information चाहिए than only ground truth. मुझे measurements भी करने हैं, sample plots डालने हैं, मुझे देखना है किस species की dominance है वहाँ पे, और उसके according to मैं should I call it sal dominant forest or oak dominant forest or teak dominant forest. So मैं dry deciduous बोलूँ, moist deciduous बोलूँ, सेमी एवरग्रीन बोलूँ. सो उस तरह की चीज़ों को करने के लिए many a times people do this. और इस information को, this is again a field knowledge, ground truth, is being used to train your computer to make type maps. And people are able to do beautiful job, preparing forest cover type map for such a big country and with such a phenological variation across, latitudes. So such type of things could be done. And this is true for, one of the toughest, most diverse, rugged terrain of the country, Northeast Himalayas. So even you see the number of classes. I am 100% sure you are not able to read those, but you should be able to appreciate the details, the degree of details which could be mapped from satellite data. And this is what Forest Survey of India has also adapted. You might be knowing Forest Survey of India ने भी forest type map बनाया है, and now it is thinking कि after every 10 years it will be able to generate that. And it has a somewhere around 14 step methodology which goes somewhere on the 12th step it tells you about accuracy assessment, and somewhere in the 5th and 6th step it tells you कि कैसे मैं उसको compare कर रहा हूँ existing database वो सारी चीज़ों से. So this is again a very nice kind of thing which people are able to do. There are initiatives from the research laboratories wherein people are further enhancing the techniques. Now, if you see the degree of details, this is 25 meter cell size vegetation type map or forest type map of the country. If you see it further, see the degree of details. ये individual plantations को भी report करता है. Whether वो eucalyptus plantation है, cassirina plantation है, उस details तक one is able to prepare database. It needs time, it needs lot of resources, like 21 institutions have participated into this. And to collect ground truth, we have gone to close to 16,000 locations to measure the number of trees and the species of all those. And then this database is globally being appreciated and is being now used for multiple applications there. This was all about the remote sensing technology which we all have. Now, the newer thing which has come is drone, UAVs, which is much closer to Earth. You are just not talking about 25 centimeters, you are talking about 2.5 centimeters, inches, sub-centimeters. Those kind of things people are trying to do. So, you simply fly over a given location and collect the information. So, the only thing is your resolution is much enhanced. You are able to see gaps within the community, canopy. एक ट्री की जो कैनोपी है उसका आर्किटेक्चर किस तरह से चेंज हो रहा है, यू नो, बिकॉज ऑफ लोपिंग, बिकॉज ऑफ इंसेक्ट्स, बिकॉज ऑफ एन नंबर ऑफ फैक्टर्स, दोज काइंड ऑफ थिंग्स यू आर एबल टू डू. ये भी डेटा ब्लू, ग्रीन, रेड, नियर इंफ्रारेड, मिडल इंफ्रारेड उस वेवलेंथ्स में कलेक्ट करता है. एंड मेनी ऑफ द फॉरेस्ट डिपार्टमेंट्स, जैसे आंध्र प्रदेश आई नो, हरिद्वार हैज़, उत्तराखंड हैज़, दे हैव देयर ओन ड्रोन्स and they are able to take benefit of this technology for detailed mapping. And believe me, day is not far, you know, when people will be saying कि मेरे पास इतने पेड़ हैं, Centrum album, you know that, you know, चंदन, आप तमिलनाडु में जाइए तो एक एक पेड़ अकाउंटेड है, आप एक पेड़ को काटिए तो there is whole lot of procedure to cut that. So same thing is happening with our forest resource also, unless we challenge the carbon credit and we do something कि पूरा प्रोसेस रिवर्स हो जाए. नहीं तो ऐसा भी दिन आ सकता है वेयर इन यू विल बी मैपिंग दिस काइंड ऑफ थिंग. अनदर वेरी प्रॉमिसिंग टेक्नोलॉजी इज लाइडार. इट इज कॉल्ड लाइट डिटेक्शन एंड रेंजिंग. इसमें क्या है, इट इज पल्स. द पल्सेज आर गोइंग, दोज आर स्ट्राइकिंग बैक, एंड देन यू आर एबल टू डेवलप आर्किटेक्चर ऑफ ट्रीज. आर्किटेक्चर से ही हम लोगों को स्पीसीज पता चलती है, यू नो, जो हम लोग फॉरेस्ट्री में पढ़ते हैं तो कैनोपी आर्किटेक्चर से ही वी गेट टू नो वो महुआ है, तेंदू है, टीक है, चीड़ है. सो सेम थिंग इज कमिंग हियर. इट मीन्स यू आर एबल टू यूज दैट नॉलेज बिकॉज यू आर प्रोसेसिंग इन कंप्यूटर. सो एवरीबडी टॉक्स अबाउट आर्टिफिशियल इंटेलिजेंस एंड दोज ऑल काइंड ऑफ थिंग्स. सो आप उस तरह की नॉलेज को भी कैप्चर करके यू आर एबल टू क्रिएट मच बेटर डेटा सेट्स एंड ऑल. And these all kind of things are being generated using LiDAR technology. So this is, we carried out one of the exercises for, you know, I am not able to disclose that location, but for them we generated tree profiles, point cloud, tree count, even tree species. And there are many agencies in the country, those which are in conflict with forest department, and they want to know this because you are asking कि हमारे इतने पेड़ चले जा रहे हैं, सो इतना कंपनसेशन है. सो दे वांट कि हर ट्री को आप काउंट करो और स्पीसीज भी बताओ. सो वहाँ पे यू नो सच टाइप ऑफ टेक्नोलॉजी इज बीइंग यूज्ड. सो इट मीन्स यू कैन मैप एनीथिंग एंड एवरीथिंग विच इज देयर इन योर कस्टडी, विच यू आर यू नो टेकिंग केयर ऑफ. और जो नया जो यू नो साइंस आ रही है, पीपल आर टॉकिंग अबाउट हाइपर स्पेक्ट्रल रिमोट सेंसिंग. सो टिल नाउ most of the remote sensing is either in 4 bands, 6 bands, 7 bands, और आप बहुत ही ज़्यादा रिच हैं तो 36 bands. लेकिन academicians are saying I can capture information in 225 bands, 300 bands. I can tell you whether it is Pinus roxburghii or Pinus wallichina. And you all know, you know, field में देखो people देख के भी लोग नहीं पहचान पाते ये wallichina है कि roxburghii है. That is, और Pinus khasiana है. But you know, science is telling us that I should be able to map these kind of things. And very soon, you know, a country has already launched a satellite which is collecting information in this. So even such kind of things will come into picture and people will be doing all those things. GPS survey is nowadays something very common thing, and most of the forest departments are able to do it. You are using differential mode of GPS wherein you know one of the location जहाँ पे आपको actual position पता है and the rover is able to tell you कि कहाँ कहाँ गए हैं and those corrections you are able to do. So what we want to do, जो हम फील्ड में मेजरमेंट करते हैं, जो फील्ड में जो चीज़ है उसको मैं सैटेलाइट डेटा के साथ कैसे कोरोबरेट कर सकता हूँ. सो फील्ड में तो यू आर एबल टू कलेक्ट लॉट different kind of information, and I just want to bring it onto a remote sensing platform. So what we are doing is we are taking advantage of multi-scale data set. AWIFs somewhere around 56 centimeters, LIS somewhere around 23.5 centimeter, LIS 3, LIS 4 somewhere around 5.8 centimeter. Then I have Cartoset 2.5 centimeter. Then I have ground. If I can transit between these special resolutions, तो मैं ground data को भी उसके साथ integrate कर सकता हूँ. So जो मैं ground में information collect कर रहा हूँ, I am trying to play with these kind of satellite data sets. And Google Earth Engine, word has gone beyond Google Earth. There is now Google Earth Engine. So all kind of data sets are hosted over there. So people are using such type of things. And many a times you do this, जो आप लोग बोलते हो stratified sampling. You carry out stratification of your area and then identify where to put the plots. So I can do this stratification using satellite data and then I can collect the ground reality. So why this all funny kind of things are being done? This is one of a very dynamic landscapes of the country. One mining, another shifting cultivation, and this is 1980s, 89, 95, 2000, which we have prepared using satellite data. What I should be able to do by looking at this, I should be able to comment on the land dynamics which is taking place. I should be able to give recommendations onto the land use policy. Probably we are one of the poorest country in terms of land use policy, and that is for many of the reasons, and that brings many of the challenges. So using such type of temporal satellite data sets, you should be able to see actually ground में क्या हो रहा है, forest किस लिए कट रहा है. It is just not for one thing. There are multiple dimensions which are associated with this. I should also be able to understand कौन से एरिया ऐसे हैं जो इंटैक्ट रहे हैं पिछले 20 साल में. So मेरे पास जैसे ही ये टेम्पोरल डेटा सेट है, मैं बहुत सिंपल रूल अप्लाई करके I can find out the locations which are intact. I should be able to tell you if business is as usual, like this is example of Dehradun, 1999, 2001 and 2006, what will be the scenario in 2010 and 2015? So I should be able to do something called as predictive modeling. So what will be state of affairs in any of the resources or say forest 10 years down the line. और आज की तारीख में when we modeled it, we did it somewhere in 2010 I believe, or no, 2008. So when we modeled it, our accuracy was around 72% modeling accuracy. But when I see actually on the ground, it is as good as 80%. So the kind of changes which are taking place on the ground, actually one should be able to predict such kind of things. Not only this, you all are into protected area management. एक protected area, दूसरा protected area, you want to maintain the corridor. And why? You want to see if corridor is diminishing. And there is a beautiful story behind this, I had been to one of the MCTs with some of the IFS officers, and there was one of the gentlemen who was part of Rajaji National Park then, some Mr. Pandey. When he saw this example, he said कि हाँ, जो आप कह रहे हैं, कहीं ना कहीं ऐसा हो रहा है. Why don't you look at larger landscape? So he promoted me to look at Rajaji National Park and Jim Corbett both as a pair. And then when we looked at this, we tried doing a modeling for movement of animal. So what you see, this red line between Rajaji National Park and Jim Corbett, this is a corridor, which I have not constructed. Computer had actually prepared that for me. I have prepared rules. I said animal can move from such type of pixels. ये slope, इस तरह का aspect, distance from road, distance from water body, this forest density, this forest class, and I get a clear-cut corridor. Same thing when I do it for 2015, which is a predicted map. So I am able to see somebody is able to come out of Rajaji National Park, gone, lost. Somebody is able to come from Jim Corbett, lost. Then I make my rules lenient. I say you can go to agriculture areas, you can go to roads, you can go to thin forest, you can go to any kind of landscape. The moment I do it, I get a corridor which is shifted 1.5 to 3 kilometers towards south. इसको हम लोग बोलते हैं human wildlife conflict. And you handle it with a different kind of language. You have to distribute so much of compensations to local communities and all. So such kind of things even could be done. Forest fire is very common. People are able to map it, look at what way resources are being destroyed. 11th February 1994, 27th March 1994. See the variation. Simlipal Tiger Reserve in Odisha, and within few seconds, giving few of training sets, I should be able to tell you how much area is actually burnt. कितना, burnt area क्या है, कितना destruction हुआ है resources में. So such kind of things one should be able to do. And there are multiple sensors as on date which could be exploited for such kind of information. And most of these things are openly available. I should be able to generate a model and I should be able to predict locations which can catch fire in the coming summers, so that you can invest on creating fire lines, clearing things. But unfortunately, things are not taking, that kind of action on the ground. और आज का अगर आप newspaper देखें या पिछले एक हफ्ते से देखें तो entire Uttarakhand, you get to see random, forest fire के incidences happening here and there. So such kind of things are there. But it needs lot of, utility in terms of decision making and all. Then the kind of activities which we are talking about, अगर आप कुछ investment करते हैं ground में, and somebody is funding you from Europe or Sweden or America, so that person is interested to see what kind of changes are actually taking on the ground. So most of the watershed development programs are actually monitored using satellite data. They try to see on satellite data the variation, and this is actually the field photograph of the same location for the respective years. And then you get to see the way, your investment has resulted into something, and you get to see these things. Not only this, if you talk to people, we generally call it PRA or FDGs, wherein you are talking to people, trying to understand from where they are collecting their resources, where they had conflicting issues and all that kind of knowledge, if being plotted on ground, मैं उसको GIS प्लेटफॉर्म में बड़े कन्वीनियंटली ला सकता हूँ. सो इसका मतलब जो कम्युनिटी इन्वॉल्वमेंट की जो हम लोग बात करते हैं, इंटरेक्शन की जो बात करते हैं, वो सारी चीज़ें भी GIS इन्वायरमेंट में बहुत कन्वीनियंटली आ जाती हैं. और मैं उसको सैटेलाइट डेटा से भी कोरोबरेट कर सकता हूँ. एंड द सैटेलाइट डेटा विच आई एम शोइंग यू, इट इज़ ऑफ 25 मीटर सेल साइज, एंड आई एम टेलिंग यू कि द बेस्ट स्पेशल रिजोल्यूशन इज 25 centimeters. So you can imagine, the degree of details which are available today with us. As I said earlier, day is not far when we will be doing tree mapping only. Punjab, Haryana, these things are being done. So you are getting high resolution data for doing this. And academicians like us, we are developing algorithms कि maybe 5 years, 10 years down the line, जब actually मुझे tree map करना होगा, so I will have ready-made algorithms. You put your satellite data and you are able to see each and every tree over there. So in many of the locations we have tried doing this, roadside plantation, block plantation, and our accuracy goes somewhere around 80% to map these kind of resources. Then people are also conceptualizing, again from a very academic view, कि कोई भी लैंडस्केप है उसके मैं ऐसे 3D मॉडल्स बना सकूं, ताकि when you are talking about states will be earning revenue from tourism in protected areas and all, why should I pay 500 rupees in Sariska where I don't see any tiger? Rather, before paying you 500 rupees, I will ask you from where shall you take me? And this is very brutal truth, but this is going to happen, and in many parts these kind of things are happening, and you need such kind of architectures for your protected areas, so that if a well-aware person is coming to take some benefit, or you are drawing some revenue from that, so one is able to see these kind of things in advance. आपको ये बड़ा hypothetical से बात लग रही होगी. Let me give you, आज से 15-20 साल पहले जब हम लोग बोलते थे कि GPS से चीज़ें locate हो जाएंगी, so many of the officers और especially decision makers को जब हम ऐसी बात बोलते थे, they used to smile. वो बोलते अरे सर इसमें बहुत टाइम लगेगा. But you see Uber, Ola, वो क्लिक बाद में करता है, आपको पता चलता है 1 मिनट में आने वाला है, बस पहुंच गया है. That is the word which I have seen at least transitioning in just in the window of 20 years. So these things are bound to happen, and I am just challenging the young officers in this. You will have to learn the trick of the trade, because coming time is going to be such type of word. और ये 2030 ऐसी थोड़ी SDGs ये सब बातें हो रही हैं. It has some meaning, and they will come as a pressure onto you. So better, you get adapted with these kind of tools. Otherwise, you are able to predict distribution of invasive species like we did it for lantana and all. We are also looking at, in light of climate change, how species movement will take place. And this is we did for Himalayas again, Banj oak, Kharshu, Moru and pine, wherein we very confidently say Banj oak and pine is going to higher altitude. Kharshu is coming down, Moru we don't know. So such type of things are being done. And this is a typical modeling exercise. Somewhere else, people sitting in somewhere else, they are actually looking at satellite data and mapping it. And they are telling us in last 4 decades, there is a shift of 300 meters in timberline. Globally, when you say 1.5 degrees Celsius, 2 degrees Celsius, it has actually some implication on this. It will have much larger implication in ecosystem management and all the kind of services which downstreams are coming. But this is somewhere true. At the same time, we tried mapping using satellite data. As I was just telling you, Uttarakhand mein forest cover increase ho raha hai. That is actually true. In many of the mountainous areas where land is now being abandoned, green cover is coming. And they are getting converted into, so we call it browning of planet, greening of planet. So there are evidences wherein planet is becoming greener. So these kind of things are incentive to people who are actually looking at green cover as a resource, you all. So those, even such kind of things could be very nicely done. When I speak about all these things, many of the officers feel कि ये तो बड़ा महंगा काम है, आपको computer चाहिए, आपको data चाहिए, all those kind of stuff. We are living in a world of open and free. Lunches might not be free, you have to listen to me for that poor lunch. But these softwares are free, these data sets are free. कुछ नहीं, आप 1970s से लेके अभी तक का डेटा आपको किसी भी एरिया का चाहिए, you should be able to download 30 meter cell size. 20 meter cell size since 2015 till date, anywhere in the world. Many a times, we had come for hands-on training, and colleagues from Terry and many of the officers here, they know कि जैसे हम लोग आज की तारीख में आए हैं आपके पास, so ठीक 5 दिन पहले, 2 दिन पहले का we have bought the satellite data just to show you how real time the technology is. So most of these data sets are free. Many of these softwares are free. Again, I will urge the young officers. Believe me, the master's student who comes to me for doing dissertation or PhD, I give them 2 hours a day, 15 days to learn one software. If they know double click, not the single click of Facebook, like wala nahi. Double click is something else, single click is something else. People who use computers, they know it very well. So अगर उनको double click आता है, so वो बड़ी जल्दी सीख जाते हैं. अगर वो Facebook वाला click आता है, तो उनको थोड़ा सा ज़्यादा समय लगता है. Otherwise, this is my very practical example, just not with 1, 2, 3, 4, around 15 to 20 students. Learning any of these first 3 softwares, it hardly takes 2 hours a day, 15 days. All manuals, all data sets, those are freely available over there. I am not asking you to become GIS professional. I want you to become GIS literate, GIS aware, so that if you actually want to take work done through somebody else, you should know what kind of possibilities are there. This you can do only when you soil your hands. Otherwise, वो नहीं हो पाता है, honestly. You simply say, मैंने वहाँ देखा था, that kind of thing. Many a times people speak that way. Now, as I was telling you, a Google Earth engine has come. You catch hold of any BTech student, not a computer science graduate, any BTech student, even including civil engineering, और उसको समझाओ भाई देख Google Earth में डेटा ऐसे है, मुझे इस डेटा से ये चाहिए. वो थोड़ा सा हाथ पैर हिलाएगा, and one will be able to give you the output which you want. This is the, वो मोदी जी बोलते हैं ना demographic dividend. This is the dividend which we all have. But before that, you actually need to know what possibility is there. And for that, you need to hook on to such type of softwares and data sets. I go to CAG for, capacity building of auditors and all. और वो लोग अक्सर ये सवाल पूछते हैं, कोस्टल एरिया से भी आते हैं, सेंट्रल इंडिया वो सबसे, कि सर ये जो प्लांटेशन ये सब करते हैं ना, इसको मैं कैसे देख सकता हूँ उसने शुरू किया कि नहीं किया. I am very sorry for this, but they literally ask this question. Then I tell them, "Arey, don't do anything. You simply go to Google Earth Engine. See this area, this is from Andhra Pradesh, 10 by 11 kilometers, 2013, you see the difference? You are able to see those dots. 2017, 2019, now you should applaud for the officer who has actually done this plantation. This is a success story, how a barren area has been actually converted into, if not forest, tree-clad area. So this is how, many a times I motivate most of the auditors, ज़्यादा कुछ नहीं करना है, आपको सिर्फ इतना देखना है और आपको फेयरली आइडिया लग जाएगा, बाकी टेक्निक्स तो आपको पता है, बुक्स कैसे मेंटेन करते हैं, दोज ऑल काइंड ऑफ थिंग्स. दिस इज व्हाट टेक्नोलॉजी टेल्स यू. अगेन आई डोंट थिंक देयर इज एनी कॉस्ट इन्वॉल्व्ड इन दिस. ऑल स्मार्टफोन होल्डर्स, आई बिलीव everybody should be able to do this. So this is how technology is being used. Now coming to the topic which we are here today. So this all started with CDM, and we know the state of CDM, and specifically for land use, forest cover and all, it was not a very promising exercise. Though people still say there are some rays of hope, but still more or less we do understand, it was a agreement between developing and developed countries. Those kind of stuff was all around that. But what has come very promising is RED, and more than RED plus. And it specifically talks about reducing emissions from deforestation, reducing emissions from forest degradation, conservation of forest carbon stock, sustainable management of forest, and enhancement of forest carbon stocks. For all these things, remote sensing can actually provide you, GIS, GPS technology can actually provide you very promising inputs, and people should be able to do it. And subsequently, things have actually matured, and in coming COPs, we will get to see many newer things coming. Then people started talking about nationally appropriate mitigation actions. All countries are, there is a saying, one size doesn't fit all. So it is same like that. So all countries were not able to do in the same ways. So there were nationally appropriate mitigation actions which were proposed and which have come. What actually has happened from CDM to RED, from to NAMAs, and now INDCs? Things are becoming very, very user friendly. As a resource manager, you are much more equipped with many of the things to design your things in your own way. Just follow the protocols which are given by IPCC, and you should be able to convert that state of affairs into a fruitful decision making and maybe a wonderful business model. And that is most of these things are actually telling us. So what all these people are actually looking at, that you should have a very educate kind of approach. It means it should be able to represent land use categories and the conversions which are taking place, which are linked with carbon. It is as simple as that. It means tree cover and the type of tree, and if it is getting converted into something else. It means if you are losing something or if there is some increment. So in the morning somebody was talking about how much carbon dioxide a forest can sequester. It is somewhere from 4 to 40 ton per hectare per year. And in the earlier stages of growth, from 0 to 20 years, that is the potential which tree has. And this tropical dry forest, the region which you are managing, that is the one which is very efficient in sequestering carbon. Temperate forest and all, those are not that efficient. Your landscapes are much more efficient to do it. So you actually need to account for each and every tree or tree glide area which is over there. The second thing which it asks you is, it should be consistent. It means that you should be able to represent land categories consistently over the period. अब ऐसा नहीं है कि आप कोई बहुत कोर्स रिजोल्यूशन डेटा यूज़ कर रहे हैं और आज की तारीख में बहुत हाई रिजोल्यूशन डेटा यूज़ कर रहे हैं. You will not be able to maintain consistency in your monitoring or assessment. It should be complete, in the sense it should be able to do accounting for all land use, land cover, and should be able to tell you what kind of changes are taking place. And the most important is transparency. And this is what is a blessing to remote sensing community. कि ट्रांसपेरेंसी लानी है तो आपको कोई अनबायस्ड फोटोग्राफ, अनबायस्ड डेटा सेट लेना होगा. अगर अभी कोई फोटोग्राफर आपकी फोटो लेने लग जाए एंड यू एक्चुअली गेट टू नो कि वन इज टेकिंग योर फोटोग्राफ, ऑटोमेटिकली यू विल स्ट्रेच योर और you will inhale. It depends on the architecture. But you will make all efforts to get the best picture. But this poor Earth doesn't do it when satellite is taking picture. Because it doesn't know when it is being photographed. So ये जो चीज़ है इसमें, this is something very important. And that is probably the reason remote sensing is seen as the best evidence for all these kind of accountings. So it provides you a very adequate process, consistent, complete, and more so transparent, so that you can describe it in the best way. So over the period, most of the countries, including us, we have come from different phases. You know, मैं अभी शर्मा जी को बहुत seriously, मजाक में नहीं, I was calling him carbon credit man. He has actually invested his best of the, what we people say na, कि time without tension, post-retirement age, just to learn this and refine these kind of things. So strategy development, making things much more ready and implementing it. So those, this entire story has taken, seen the different phases, and today we are with some of a very good learnings, you know. Okay. So what we want to learn from here, you have forest and you have non-forest, and in entire tropical world you have the connection between these two. If something is changing, it is typically going from forest to non-forest areas. But in last few decades, we have seen that forest areas are also coming back. See the policy of China, greening the landscapes. They have done conservation plantation, they have done energy plantation, they have done all different, 4 different type of models they have applied. So you get forest which get converted into non-forest, and then you can also get back it to forest. And this is what your satellite data should be able to map, whether your forest is intact forest or it is a, you need some kind of management which is resulting into some degradation and all, or you are carrying out afforestation or reforestation kind of activities. These are the 4 things: conservation, sustainable forest management, and carbon stock, enhanced carbon stock, which is it is resulting into. And this is what you have to report, nothing more than these things. So you have some activities which are taking place on the area. You have some emission factors, maybe leakage or some other kind of additions or subtractions, and you have to ultimately tell how are you contributing to sequestration of carbon dioxide. Again, you know, in the morning session we were discussing, the entire story is around carbon dioxide as on date. जैसे जैसे हम carbon dioxide release कर रहे हैं या capture कर रहे हैं, entire market is driven by that, and most of our decision makings around this. I am just talking to foresters, if I talk to agriculture scientists, if I talk to water resource managers, उधर भी carbon dioxide ही ज़्यादा important role play कर रहा है. The newer thing, if somebody is interested in academics and all, nitrogen is coming as a newer thing. You know, oxides of nitrogen, aerosols. So those are building up newer story, and maybe 5-10 years down the line, you will get to see another indicator of climate change. But till then, you all are, you know, in a very cozy situation to use these all things. So what you do, you have different phases. In all of the phases, satellite land monitoring, that becomes somewhat very important. You are trying to see what was there in past, what is there in the present, and what kind of transition has taken place. To do it, you need to have your experimental site, which you call as your project site, and you need to have your control site, which we generally call as your reference site. By design, by nature, both should be same in terms of area, same in terms of the forest type or land use practices which one is referring to. Then only you are able to say, in my experimental site, there is some kind of enhancement which has taken place. So to do all these kind of things, you can use anything which is around. You can use drones, but you need to maintain that consistency. You can use aerial data sets, again you need to maintain that consistency, or you can use satellite data sets. So all these flux stars, kuch bhi boliye, you should be able to use. But to maintain consistency, you need historic data set. You know, you have a baseline, or fortunately, Landsat is only data set which comes with that continuity. Since 1970s, you get to see Landsat. Landsat 1, 2, 3, 4, 5, 6 was not there, 7, 8, and now Landsat 9 has come into picture. अगर आप recent देखें तो few months back Landsat. And the beauty is, NASA has maintained a consistency in spatial resolution. Except Landsat 1 and 2, everything is in 30-meter cell size. Same type of spectral bands. When I say near infrared, it is मेरा वाला near infrared. 0.1 इधर भी नहीं, 0.1 इधर भी नहीं. It has maintained the wavelengths in micrometers. So that provides you a wonderful opportunity to do this. अगर baseline change होता है, 2015 की बात होती है, so probably LIS-3 will become a main actor, जो indigenous satellite है, Indian remote sensing satellite का, with 3.5 special meter resolution and with 4 bands. So one should be able to use LIS. So though drone is very promising, it is giving you a lot of information, but for such type of projects, probably drone doesn't come as a ready-made solution because you can't see the historical things. You can just see now or maybe future. अगर आपको पूरा window cover करना है, so you need to rely on Landsat, or depending on time frame, you can rely on LIS-3. And interestingly, the information which we have in country, as I told you, the first mapping was done with using satellite data of 1972-75. That was again done with Landsat. The second mapping was done in 80-82. That was again with Landsat. And then 87, 89, 91, 93, 95, up to 97 if I am correct, all were done with Landsat. 99 onwards, you get to see even with 2021 report, all are being done with LIS-3. These all maintain the consistency of spatial and spectral resolution. So end of the day, you need to refer to this document for looking at what you are reporting, because this is one of the most authentic documented information on forest cover in the country. So that promotes you, that actually motivates you to use Landsat for such type of studies. So most interesting thing when forest officers are here and your range officers are here, you all are in one or the other way associated with working plans. Sometimes you take the responsibility of doing that. Sometimes you provide inputs to those. So many of these things, in addition to the changes which have taken place since 1891 to 2014, these all are going towards aligned with sustainable development goals or the mechanisms of carbon credit, conservation, these all kind of things. So somewhere you are into generation of such type of information. सिर्फ आपको क्या करना है, थोड़ा सा और systematic temporal data set उसको generate करना है और field data. So in a sense you are half prepared. The way I understand working on preparation of such kind of documents. So you should be able to take benefit of such type of information which is around. So typically, globally, people talk about 5 pools of carbon. Tomorrow, probably Aniket or Yogesh will be talking in this in some details. But it is essentially you have above ground biomass, which is measured using girth and height volume equations, specific density, all volumetric equations and all. But you can correlate those kind of information with satellite data, either with area or with spectral information. Another is below ground. We have typically good understanding about 20 to 29% looking at the different geographical areas, what kind of ratio exists over there. The third is dead wood and the organic matter which is getting accumulated with this. This is probably the easiest thing to assess, or everybody can do it very nicely. Litter again plays a significant role. Then comes your soil organic carbon, which is, you have to dig out soil with 10 centimeter, 15 centimeter using the protocol. And then there is a black and clay method, which is used, a titration method, which is used to estimate organic carbon. Not a very big deal. You get to see many people in market, those who provide consultancy services to estimate these kind of things for you. So historically, people were using more of a destructive methods for such type of things, but as remote sensing came into picture, people were able to use satellite data to correlate your volume and biomass onto that. The beauty is, there you were able to do with stand level or individual tree level. Here, per pixel level assessment could be done. It means larger the area, more extrapolation, but with a degree of uncertainty, you are able to speak things in per pixel level. People also use GIS, again another way of extrapolating information. Here again, up to per pixel level, one is able to do this. When you are doing remote sensing, you are essentially using spectral band information. जब आप GIS यूज़ करते हैं तो जो terrain factors, topography factors होते हैं, altitude, slope, aspect, उसको भी लोग generally यूज़ करते हैं इसको करने में. Again, the same thing, spectral signature curve. So now if you see this curve, this is specifically for vegetation. अगर आप देखें तो ब्लू में डिप है, रेड में डिप है, दिस इज फोटोसिंथेसिस. हम लोग बचपन से पढ़ते आ रहे हैं कि फोटोसिंथेसिस ज़्यादा एफिशिएंट होता है 690 नैनोमीटर में, रेड में, ब्लू में भी होता है, बट द एफिशिएंसी इज नॉट दैट. ग्रीन इज बिकॉज इट इज रिफ्लेक्टिंग बैक. जस्ट उसके नेक्स्ट, जैसे ही आप रेड के नेक्स्ट जाते हैं तो यू सी अ बाउंसिंग, दैट इज नियर इंफ्रारेड. ये रिलेशनशिप बहुत इंपॉर्टेंट है. 1976 में देयर वाज अ पर्सन राउस हु हैज कैप्चर्ड दिस इंफॉर्मेशन कि दिस healthier the vegetation, more dip will be in red and more bounce in near infrared. और जैसे जैसे vegetation की health कम होती है, red में reflection कम हो जाता है और near infrared में भी reflection कम. So वो absorption कम हो जाता है red में और near infrared में reflection कम. So ये जो edge है, लोग इसको red edge भी बोलते हैं क्योंकि ये just immediate after red है. So people have tried tapping this. और वो सर्ट्स हम लोग पढ़ते थे, कंपेंडो डिविडेंडो. एक सिंपल सा फॉर्मूला डेवलप किया गया है विच इज नियर इंफ्रारेड माइनस रेड अपॉन नियर इंफ्रारेड प्लस रेड. इट मीन्स इंफॉर्मेशन कैप्चर्ड इन रेड एंड नियर इंफ्रारेड बैंड इज बीइंग यूज्ड टू नॉर्मलाइज एंड दिस इज कॉल्ड एज नॉर्मलाइज्ड डिफरेंस वेजिटेशन इंडेक्स. वन ऑफ द इंडिसेस विच इज ग्लोबली बीइंग यूज्ड एंड दैट इज proportionate to vigor, green cover, proportionate to carbon, biomass. So इस तरह से this information is generally used over here. It is just not at local level people do it, people use this for the global analysis also. Global level में vegetation analysis में people are able to use such type of things. You see India and you probably know vegetation or the density or much better. So NDVI is very proportional to the kind of quality of vegetation which is distributed around. So when you do carbon measurements, so field inventory is must. Uske bina nothing can be done. That is for sure. Remote sensing can help you a lot. One can develop a model. Model here means simple equation, relationship between your biomass and the NDVI which is over there, and then you can see the periodic changes, whether there is an enhancement in biomass or biomass has gone down, depending on your temporal data and the reflectance patterns जो वहाँ पे हैं. So generally जब हम लोग बात करते हैं and the way methodology is being developed in the country, so everybody talks about optical images. Optical means the one which are being captured in blue, green, red, near infrared, middle infrared. There is a community which also talks about radar, which is microwave, very larger wavelengths, but people have not found it very successful. And people also blend your optical and radar to do estimates and all. So using any of these methods, one should be able to arrive to biomass. But looking at convenience and all the characteristics of our measurement, most of the time we look at optical remote sensing. So you can get a direct assessment because there are much of experimental data. There are permanent plots which are distributed around the world. So people are able to use those also. But because you are working in smaller areas and all, so it is always advised to do your own kind of empirical modeling for these kind of things. So basically what you do, you have a volume which you are estimating, and you have a reference data for that using LiDAR or satellite data or combination of this. You are simply plotting such type of correlation and the equation how your biomass is dependent on vegetation indices and all. So people have found pretty decent value. When I say pretty decent, statistically somewhere R square of 0.6 to 0.89 kind of thing, and which is considered a very good value when it comes to communities which are using biomass. ये depend करता है कि किस तरह के vegetation types की आप बात कर रहे हैं. कहीं vegetation types खासतौर जहाँ पे evergreen and semi evergreen होते हैं वहाँ biomass saturate कर जाता है. So उधर कुछ uncertainties हो सकती हैं, but in most of the dry deciduous, moist deciduous, temperate, people are able to see 0.7, 0.8 kind of relationship, something very good. People have also developed models using satellite data and correlating with leaf area index or biomass. There is projection of leaf, वो भी vigor और health of vegetation को ही बताता है. So This is example from Western Ghats in India. So such type of models are also available. So people are able to triangulate or corroborate information from different dimensions to see that NDVI stands to be a very good candidate for this. In coming years, it may happen with very high resolution data, people will be able to construct models to directly assess the biomass, looking at the architecture of the trees and the species which are over there. But this is very experimental. It is nothing which is well established. But there are always some people who are more interested in research kind of thing. So one should be able to look at this story. So indirect method mein you have more of a land use, you know the distribution of your class land use and for number of sample plots, and based on that you try to extrapolating it. It is again good, and it gives you a good information on historic distribution and all, but not always. People can always look at the kind of advantages which are there, but probably the audience here, आपको disadvantages में ज़्यादा interest होगा. People generally find it, technically something very, but believe me, it is not that rocket science. It is something very simple. You have some numbers which are coming from field, some numbers which are coming from satellite data. You are simply putting a regression equation between that, nothing more than that. And R square you are just trying to monitor कि मेरा 0.6 से लेके 0.9 तक आ जाएगा, तो you find it somewhat very convenient. People say it is very costly technique, not at all. As I just showed you, most of the data sets are freely available. Most of the softwares which one should be able to use, those are freely available. So it is not that. You need some kind of technical knowledge to do it, but you need not to be expert in those kind of. If you understand कि remote sensing data आपको क्या दे रहा है और आप field से क्या ला रहे हैं और उनके बीच में connection क्या है, then you are able to translate that into a good document which people should be able to appreciate. Verification of results, to best of my understanding, I don't know biomass को कैसे verify करते हैं, honestly. If somebody says it is 460 ton per hectare, somebody says it is 480 ton per hectare. So the only method which ends is destructive method, which we are not able to do. So, but one shouldn't worry much about these kind of things. But still, these are some of the disadvantages. But when you look at advantages and all, then you find that it is a good proposal to use remote sensing for biomass estimations. So TERI has carried out activities in different parts of the country, and I got opportunity to participate with them and support them with my remote sensing understanding and all. So this is somewhat 9-step kind of methodology which is there. The first thing is you define the boundary. This is the foremost thing. Many a times you have boundaries for your JFMCs, one panchayats or other kind of things, or when you are talking about your protected areas. But if you are identifying something as a definite project area, so आपको simply GPS use करना है, and anybody can take that GPS, take a round of that area and generate a boundary. और मतलब it hardly takes how big your area is, what kind of perimeter is, उसके basis पे time depend करता है. Otherwise it is one of the easiest exercises. आज से if I am correct, around 13 years back, आंध्र प्रदेश डिपार्टमेंट ने GPS से पूरा फॉरेस्ट का बाउंड्रीज को डिजिटाइज कर लिया. दे सिंपली हायर्ड फ्यू बॉयज़ और उनको बाइक में बैठाया विद अ DGPS और पूरा फॉरेस्ट बाउंड्रीज उन्होंने, देयर वाज सम मिस्टर रेड्डी IFS ऑफिसर देन, सो ही गॉट इट डन. जो अभी DG हैं FSI के, ही वाज आल्सो इन्वॉल्व, डॉक्टर अनूप सिंह, सो दे कुड डू इट very nicely. I am talking about 13 years back. So it means this is not a very big deal. Second is selecting the carbon pools. Essentially, you all should select 5 pools of carbon. Stratification of your project area, you need a mapping, density mapping or type mapping, both. So that you can see what type of forest is there or kaun si density hai. Like you have moist deciduous, how density classes, what density classes exist there. Dry deciduous forest, what density classes exist there. It helps you to stratify your samples. We say strategy part to proportion. जिसका एरिया ज़्यादा है उधर आप ज़्यादा सैम्पल प्लॉट्स डालिए, जहाँ पे एरिया कम है वहाँ पे कम सैम्पल प्लॉट डालिए, सो दैट योर रिलेशनशिप विल कम वेरी नाइस. इफ़ यू डू वो व्हाट स्नोबॉल सैम्पलिंग और कोटा सैम्पलिंग, तो यू ऑलवेज कम लाइक वो जो प्राइम टाइम में न्यूज़ में आता रहता है. You will always be discussing those kind of things. Use science, use statistics. So उसके लिए आपको टाइप और डेंसिटी मैपिंग करना है, so that you actually know sampling कहाँ पे करनी है. And once you know that, you put your sample plots, carry out your field measurement. Nobody else knows better than this, you all. कि कैसे सैम्पल प्लॉट डालना है, कैसे उसको मेजरमेंट करना है, उसकी अकाउंटिंग कैसे होती है. और एंड देन यू असेस योर अबव ग्राउंड बायोमास. यू हैव अ बुक published by Forest Survey of India which says volume equation something, I forgot green cover ka. It is a very nice book. All over country for most of the species, even subspecies, region wise, it gives you volume equations. So that is something, the text which is available. जो नहीं है उसमें, अगर आप publications देखें फॉरेस्ट रिसर्च इंस्टीट्यूट के और some of the academicians from best of the universities in ecology and botany, forestry, you will get to see many of the equations which are coming. So you just need to convert that into above ground biomass, below ground biomass. Weighing your litter, weighing your deadwood is not a tricky thing. Soil organic carbon, you need to collect samples. There is a standard protocol for that. You just need to follow. Once you have done that, then you are able to actually estimate what kind of biomass is there. As I was telling you, Terry tried doing it in different parts of the country. These are 5 locations in Odisha, in Jharkhand, Central India, Madhya Pradesh, part of Uttar Pradesh and Uttarakhand. And they did a fairly good job by looking at different types of forests: Masuri, temperate forest, mixed dry deciduous forest in Renukoot, dry deciduous, moist dry deciduous in Chindwara, and then you have in Angul, Odisha, and even in mangrove forest in West Bengal. And most of these tell us that this is something quite doable. This is how a boundary is plotted. The actually boundary बनी है GPS से, जो आप yellow वाली जो आप देख रहे हैं. Somebody has taken GPS and just tried running around and created this, and the blue one was further refined to carry out stratification and all. And these are the sample plots where sampling was carried out to estimate tree height and girth, so that biomass could be done. जो आप ये बिल्कुल पेरीफेरी में देख रहे हैं, that is Sundarbans. There is a Royal Bengal tiger which resides over there. I don't think forest staff takes that courage to get into for just to measure trees and all. But jokes apart, it is quite a homogeneous area, and even at the fringes, if you are measuring it, it is fairly good enough, because you are doing stratification. Based on that, you have identified this, and once you do this, there is something called as biomass expansion factor, which is additionally used to enhance your biomass, which is basically a bowl biomass. देखा जाए तो सिलेंडर की इक्वेशन है, that is pi r square h. So you just put your biomass expansion factor over there and get the total biomass. Then these are kind of relationships which have come over there. If you see all the r square values, I was emphasizing on 0.6 to 0.9 kind of thing, 0.69, 0.78, 0.73 and 0.82. It is always good to take more plots, so that if there are outliers, people who do statistics, they understand it very nicely. If there are outliers, you can always manage with your data, because what you are telling in your data, that is what you are reporting, and that will be which will be used to monitor. But still, getting this kind of R square is somewhat very good, and this is how people do. I just helped a student to earn a PhD degree. To do that, we tried looking at, जो इतना red ये सारी चीजें कर रहे हैं, can we do it actually on some of the landscapes? So we picked up something from the southern Kashmir, which was part of Anantnag, Pulwama and Kulgam. This is how we make forest type map. So this was purely done using visual interpretation, but you can also do using digital interpretation. Evergreen forest, evergreen open forest, you have forest scrub, grassland, horticulture plantation, agriculture plantation, and even kharif, double crops, those all kind of things. But when it comes to density map, you are basically interested in only the 2-3 density classes, and then you can make things like this. And this is the regression which we plotted. We tried looking at more number of sample plots. Our R square was not that very big, but still 0.72 is good. This is which we tried doing something extra. We tried looking at कि जो मैं biomass plot कर रहा हूँ, क्या मेरा satellite data, this is a box plot of NDVI and above ground biomass. Just to see, the variation which is there in NDVI and the variation which is there in the field biomass. So we get to understand mean are lying somewhat very close by, and even the distribution is somewhat similar. So people keep on trying such kind of lateral things just to earn more confidence on the model which you are developing. So जो ये y is equal to mx plus c है, जो लोग economics पढ़ते हैं इसी को model बोलते हैं. You know, this is one of the models and probably the simplest model of the equation of a line. So this is what we are calling model over here. Otherwise, it's not that tricky. Again, you remember I told you there are 5 options which in red. So we tried to look at if deforestation is there and if we can take a halt on that, what kind of increment shall we be getting? If degradation is there, so we identified areas where enhancement of carbon stock could be done, where sustainable forest management could be done, where degradation or deforestation could be taken into care, and also conservation. So internationally, many a times people try plotting such kind of things, but the protocol which we are following, or especially for carbon market, you need not to go into such type of sub details of your reference and those kind of things. But again, as I said, you can always earn something more from your data set always. Whatsoever we are telling you, this is nothing like, as if we have generated a newer kind of knowledge over here. We have just tried learning these things, testing these things in different parts of the country just to validate कि जो हम लोग बोलना चाह रहे हैं, that is possible or not. But you all are well aware, you are well read. If you hook on to any of these books, you will be able to learn many of the things which we are discussing with you. The only option which we have is, we have a tailor-made program which we can actually tell you how this thing has been done. Whereas this to some of you might appear as if Rajnikant action, कि ऐसे कैसे हो गया. We have just tried to simplify those things. Otherwise, if you look at any of these books, these all are available PDF format में, internet में. कोई भी आप download कीजिए, इसको ध्यान से पढ़िए, you will be able to understand things pretty decently, but nothing more than what we are telling you. And this is again, bottom line. But still, reading something is always better. So आप लोग इसको देखिए, maybe you will learn something more than what you can learn in these 2 days. So this is all which I thought you should know. More than this, when it comes to databases and all, initially I told you free softwares, free satellite data sets and all. There are plenty of data sets which are available freely, which one should be able to download. You talk about forest cover map, state forest reports, vegetation type maps with 1:50,000, 1:500,000. Annually land use land cover map is being prepared using AWIFs. अगर आप भुवन की वेबसाइट में जाएंगे, भुवन is a देसी Google. जैसे आप Google देखते हैं वैसे ही भुवन है, which is very Indianized kind of thing. The beauty with Bhuvan over Google is, Google में सिर्फ आपको डेटा दिखाई देता है, सैटेलाइट डेटा. इसमें आपको मैप्स दिखाई देते हैं, थीमेटिक मैप्स. और NRSC is such a user friendly to forest department. अगर आपकी कोई specific need है, you contact the forest division over there, they will be able to generate some of information for you. So that is again is available. अगर आपको और detailed maps चाहिए, तो every 5 years they are developing it and putting it on Bhuvan. So you should be able to learn many newer data sets over there. इसके साथ साथ हमें थोड़ा सा और भी रिस्पॉन्सिबिलिटी है when we are looking at Forest Survey of India as one of a custodian of very wealthy data. So these kind of variations are there. What you see in Forest Survey of India, that is there. All plantation is also put in tree cover. Whereas if you see this map which is over here, plantation is a distinct entity. So थोड़ा सा इस तरह का differentiation we should be able to understand. What is primary forest, what is secondary forest, what is plantation. So if we do these kind of things in our assessment, probably we will be reporting something much better. If you have a plantation and you report as forest, so somebody will doubt on you, your integrity towards making the report. So थोड़ा सा careful रहने की जरूरत है उसमें, otherwise things are not that difficult to do. We need to enhance our framework of forest mapping. As of now, probably, I believe it is more of a forest resource assessment. Probably we need to bring more into looking into कौन से critical areas हैं, कौन से significant areas हैं for conservation, for making such type of projects and all. So थोड़ा सा we need to bring much better forest monitoring system over here. इसके लिए best है you start from what FSI has done for your state, and from there you try to grow further. Definitely उसमें कुछ gaps हैं. Even I know I have read the articles written by forest officers and even talked to them. So even forest officers find some kind of gaps in the reporting which is there in FSI. But still, that is one of the baselines. So you can enhance that information always. Instead of, reinventing the wheel again and again, just try starting from there and try to look at what better choices of scale or scope could be there. Believe me, if you do it today, it is going to help for many of the other things which are already part of your deliveries. It is nowhere addition to what you are doing. It is just a subset of that articulated in a different way. It is just a packaging of information which is already existing with you in the most systematic manner. So that, Terry team or people like Professor J.V. Sharma, they can help you to convert that, the data which you have into information content which becomes knowledge for rest of the country. And more the knowledge, wiser the forest department will be, richer the forest department will be. What I specifically see for Maharashtra, you have a wonderful opportunity because you have NBSS LUP next door, National Bureau of Soil Survey and Land Use Planning, which creates data sets on soils for entire country. So you have forest cover maps. So you try looking at your forest you try looking at your forest inventory maps, your distribution maps through satellite data and other. You look at soil distribution, organic matter and those kind of things which are already available with your National Bureau of Soil Survey, or looking at the facilities which are over there to help you to design things for one of the pools. Because the remaining 4 pools, you can do it very conveniently. And then generating information which could be used for vegetation carbon stock or vegetation carbon sink or soil carbon stock. Those kind of information could be very nicely generated for Maharashtra, because their physical presence here is experimenting with different scales, which is not happening for other states. So आपको बहुत बढ़िया डिटेल लेवल में soil वो सब का भी information मिल सकता है. So you are in a very win-win situation kind of thing. Then you have Maharashtra State Remote Sensing Center, which is there at Nagpur. Again, because I have worked with ISRO, so I know people there, I know the way state remote sensing works. So Maharashtra Space Remote Sensing Center is one of the excellent remote sensing centers in the country. You can find Andhra wala ko bhi somewhat very competitive in that manner, but still they are housing huge amount of data when it comes to forest types, forest density and all. So in a sense, you have lot of things which are spread around. You just need to learn the protocol which we are trying to share with you and see how this jigsaw puzzle in terms of spread out data set which is around there. You can put them together and you can come in most efficient manner with the PDs which you are supposed to prepare. So this was all which I thought I should share with you. If you have any question, I will be happy to answer. If not, she is ready to say thank you to all. Please.
Questions, if any?
First of all, let me compliment you for apprising the various nitty-gritties of GIS, remote sensing and carbon assessment by using these technologies. First of all, I appreciate. Secondly, I just wanted to know that if carbon assessment is being done by using remote sensing technique, right? And we arrive at say certain figure, say X. And tomorrow Yogesh Gokhleji will be teaching us regarding how to calculate these carbon stocks by actually visiting the sites, that is through carbon, 5 pools of carbon, and how to convert them into carbon dioxide equivalent, or they will be computing the biomass. Now, if you take these two techniques, that is using remote sensing technology for biomass calculations, we arrive at a figure, say some X. And by using sampling, ground sampling technique, we arrive at a figure Y, right? So first question is, what is the degree of accuracy? First thing. Secondly, if the carbon assessment is being done by using remote sensing technology entirely, instead of not visiting the site at all, whether it is acceptable to the these voluntary carbon market platforms like Dzire. That is the second question. If the degree of accuracy is very high, then where is the need of visiting the field and getting the raw data and again calculating it?
Well, thank you, sir. Thank you very much. I will start with your second question first. I will never recommend that using only remote sensing for any kind of interpretation. Forget about biomass. I am very responsibly, I am saying, given the 2.5 decades of experience I have in research, teaching and other kind of activities, never do that. It is always, it has to be supported with field data. Without that, you might get some number. It's just a number. I don't know what is that. That is point number one. So it has always been done this way. Second, though I do understand what you are trying to look at, but when you are just doing field work, you are randomly getting some locations and some value for that. Those are very good. They might be, I will call them very accurate. But my purpose is not that. My purpose is looking for entire project area, distribution. So if you have to do distribution, either you increase the intensity of your sampling, which is very time-taking process and cost is involved. So you increase the number of points. Even if you do that, you will never be able to do 100%. You will, at some point of time, you will have to carry out interpolation or extrapolation of that. So what we are proposing over here, we are proposing one of the data set which is available with remote sensing, field data. With a limited field data, I should be able to take benefit of remote sensing to extrapolate, which anyhow one has to do, to create continuous information. So that is there. So it has to be blended. And that is probably the reason, they pulled me here to talk to you all. Otherwise, they are very good at field works and all. So we will have to do it. Now comes the question of uncertainty. So one of the parameter which helps me to do understand uncertainty is your R square. Greater the R square relationship between your biomass and the NDVI, better it is. But we know there are certain limitations. We will never be able to get it, theoretically yes, but practically even 0.9895 is very challenging. If somebody does it, I actually doubt that. The second thing is, there could always be opportunity to, take out some of the points and not use them in developing a model, rather to validate. So most of the time, our assessments which we have done, we have never done it for the projects which I just reported over here. As an academic exercise we have done, so we get to see very high degree of correlation, which is same what my R square is able to tell me. So that is not there. What the source of error, I can always tell everybody, how do you minimize that? What could be the source of? The source of error is, how do you select your locations for sampling? I emphasize that you do mapping for type as well as density. People generally just look at type, कि चलो टीक में इतने ले लिए, साल में इतने ले लिए, तेंदू में इतने ले लिए. But it may happen कि टीक तो very dense था, और तेंदू जो था वो पूरा ओपन फॉरेस्ट था. सो वहाँ पे अनसर्टेनिटी आने के चांसेस बहुत होते हैं. सो लुक एट बोथ द थिंग्स टुगेदर एंड देन आइडेंटिफाई लोकेशंस की सैम्पलिंग कहाँ करनी है. इफ दीज प्रिकॉशंस आर टेकन, सो सोर्सेज ऑफ एरर्स कुड बी मिनिमाइज्ड. स्टिल आई से आई एम नॉट 100% करेक्ट. स्टिल आई से आई डोंट नो ऑनेस्टली कि जो मैं वो रिपोर्ट कर रहा हूँ, बट आई नो इट इज़ नॉट इनकरेक्ट. It is somewhere 80% correct, 90%. And this is how, this entire science has evolved. Even at operational level, this is how it is being done. So that is there.
accuracy part, what happens that while we do stratification, when the stratas are very big, say for example areas of Western Ghat especially. So in Koina if you go, then you have altitudinal variation, and with altitude there will be change in vegetation, but if we consider only vegetation as a strata, then within that, as Dr. Joshi mentioned, the density aspect gets overlooked. So within secondary forest, say for example, secondary evergreen forest, if we are sampling and through the satellite definitions, if we are sure that where we are sampling, that is if we are sampling in secondary evergreen very dense forest or secondary evergreen moderately dense forest, and if we are sure about that, then such kind of ground truthing information, those training sites make your estimation as accurate as possible, because then in a general extrapolation, you will be only extrapolating that particular number to the entire area of the stratum. But using satellite imagery, within that stratum, how much area is dense in the continuum of density, that you will be able to estimate and put the number as accurately as possible.
Any more questions?
Professor, it was a good lecture, and you have made, in 60 minutes you have explained the entire remote sensing GIS technology to a layman. Like, they can easily understand it. And the same thing, like out of curiosity again I am asking, Forest Survey of India report, in that report they have given some factors, and based on the forest vegetation cover and different forest types, so when you multiply with that factor, you will be getting all these 5 carbon pool calculations. Maybe हम बोलते हम जुगाड़ लगाते करके, but this is a kind of, I don't know whether it is an accurate level, whether we can mention, because in working plans we used to do this calculation. How far we can rely on FSI data, or we have to go for this specific location-wise carbon pool assessment. Is there any deviation from using those factors as per in FSI data, or we should go for field visits and this assessment?
Okay, the way I understand, there are always 2 ways of doing anything. One is actually measuring, monitoring precisely, and another is looking at a gross average values. So the numbers which you are getting in your FSI report, those are very generalized numbers. They will land up to some number which will be true, but which it will be correct, that we can't take responsibility. That is, and it is just not for FSI report, anything which is at regional, national or global level, if any numbers are there, those are always generalized numbers. They have their own purposes and they have their own importance, and modelers, people generally use that, and people should use it. But the kind of activity we are getting into, this is the one which will be monitored, which need to be monitored at a temporal scale. So you need very local specific estimates, so that tomorrow if somebody is monitoring and some variations are coming, you know the reason why those variations are. Because of the ground, it is growth, it is leakage, whatsoever. It is not because of the generalization. So when you are developing such type of PDs or such projects, in situ local scale assessments are must. Then only you will actually be able to get into market and take advantage of that. But if you just want to speak out a number, just say many people speak, so those generalized numbers are good, fair enough. That is perfectly fine, but not for this purpose. Okay. Yes, sir, please.
Thank you.
If I take example of the 5 pool of the carbon stock number, and exactly I am not remembering, but the soil organic carbon is suppose 58%. So see the 19 report and see the 21 report. And they have said, the report has mentioned that there is an enhancement of the carbon stock in the above ground that much, in the below ground that much, and leaf litter that much, and soil organic carbon that much. But I say that in 2 years, soil organic carbon does not change much. So that whatever the formula they have applied, Forest Survey of India, rather I do not know, or I fail to understand that that much enhancement might be in the above ground, that is possible, might be in the below ground because of the factor possible. But that much of the carbon stock enhancement, the soil organic carbon, that is not possible within the span of 2 years. That is why the Vera platform permits the inclusion of soil organic carbon after the interval of 10 years. So that soil organic carbon enhancement is there substantially. I'm not saying little bit might be there, but substantially. And the FSI report, same percentage as above ground, same percentage as below ground, that is possible because of the factor, but same percentage as soil organic carbon, that is, no, I'm not able to understand, and hopefully sometime Forest Service of India people, they can explain better that how they have arrived that figure. As you have mentioned that, you have to measure, you have to take a sample of your area and have the baseline and got tested in the laboratory, and on the basis of very simple formula is there. Tomorrow Aniket will be letting you know that you can calculate the soil organic carbon, and for that you may not be depending upon, that is Professor Joshi has mentioned, that is a broad data for the whole state or the whole country, but for a specific project you have to do the specific exercise for that. Thank you.
Any more questions?
Sir, in your lecture, we got to know that through above ground biomass estimation can be done through NDVI, correlation of NDVI with the ground data that we collect. But from remote sense data, how do we draw correlation for below ground biomass, dead wood, basically other 4 pools of carbon? How to go about that, sir? Because NDVI, so we, in our basic courses also, we are a bit aware of NDVI, but other things we are not aware, sir.
Others we don't do.
Okay,
Like below ground, we don't do. We have a percentage recommended by, for this activity recommended by IPCC. We take that and convert above ground into below ground. For soil, we do assessment and litter, and we do in situ measurements and extrapolate this. But remote sensing can help you to estimate soil organic carbon. Those kind of techniques are available. But that goes beyond the scope of the activity which we are doing. So we generally don't talk about that in such type of forums. But when it comes to soil organic matter in agriculture areas, open areas, arid areas, so there are well-defined methods where people are using those. And there are, typically those are called as inversion models. You learn something from here and you try to bring it up. So inversion modeling is applied for those.
Sir, say suppose we have kind of 150 hectares of forest land. Suppose that is the facts that we are looking at for a RED plus kind of project, and which have say 3 classes of 3 density classes, open and high density and medium density, 3 classes, and there are predominantly 3 forest types. So suppose one peak forest, other is mixed forest, and one is open forest. So in all of this, there would be basically 9 combinations that will come out.
Yes.
So say suppose we have 180 hectares of land, we have, so that we can divide it easily. So how to go about laying the samples, sir? Like through RS data, whatever remote sense data is there, we will divide into 9 type of forest types, and forest type and as well as density classes composites, and based on that we will have to sample for each of the classed area, and based on that we have to draw whatever regression equations and all. Is it so, sir?
Yes, actually using your 3 forest types and 3 density classes, you try to look at what is distribution of each forest type and each forest type in each density class. So by this you get a proportional distribution, which is higher, which is lesser. Then you can identify a number based on your sampling intensity and distribute that sample number across these 9 classes. It may happen that a class of a type with a density is existing there, very small, but your sampling intensity is not permitting you to put a sample plot there. But if you feel that it can introduce an error, you bring one sample plot there. So, you know, you use statistics, also your wisdom, while distributing this. So it is typically called as stratified random sampling or stratified sampling or part to proportion sampling. So that is being used. So we generally create one layer of type, another layer of density, then we cross them and we generate a statistics based on all those 9 classes in terms of hectares, and then we find out what proportion the distribution of samples will be there, and accordingly field staff collects the data from the respective areas. And we also do, which is not always done, but typically we try to give lat longs also, that this area one should go for sampling, a kind of prescribed locations. And because we know the GPS locations for those, and tomorrow you will get to understand how GPS can help you to locate a area or a point, then the field party goes to those locations and collect the samples. It all depends, the degree of heterogeneity, homogeneity, and the kind of mosaic which is existing there. So accordingly, those all sort of combinations are used.
Thank you, sir.
Pleasure.
One more dimension for using this technology is that these fire alerts are being generated nowadays through thermal band, and these fire alerts are communicated to the ground level staff. But when they verify the site, it is found that the site is outside the forest and they are located not in the forest areas, in private areas, and the damage or the extent of damage is minimal. In spite of that, the thermal band catches it up. So actually the technology should help us as a decision support system. So many times what happens is that because of these what you call false fire alerts, people are moving and they are extinguishing through SMS only. So that is what is happening, right? So what I mean to say that the technology is there, but the technology should act as a decision support system and should help us in reality in minimizing the damage. Actually, when the fire alerts are being sent, now so much of technology is available with the Forest Survey of India. They can overlay one layer of forest area of that particular state, of that particular area, and then they can send those fire alerts. In one of the case, actually, the APCC of protection is here. So he was required to travel all the way from Nagpur to Sindhudurg to check what is the extent of damage in the fire. So if the extent of fire is known on the computer itself, actually what is happening is that this technology is being used partially only. It means only fire alerts are being sent, extent of damage, extent of fire, and its location is not being sent. So because of which it is creating problem. The technology actually is creating problem for us. That is what is happening. So I just wanted to know your reactions. Thank you.
Thank you, sir. Northern India में कहावत है जितना गुड़ डालो उतना मीठा. It is as simple as that. When the way FSI is using it, the modis through which it is being mapped, वो 10:30 बजे के लगभग फोटोग्राफ लेता है. Within half an hour वो प्रोसेस करके पॉइंट्स बता देता है कहाँ पे ब्राइट पिक्सल्स हैं. वो we call it skin temperature. वो temperature estimate करता है और वो बता देता है. And that is put in their portal. That there is called Forest Resource Forest FRMIS. NASA की website है from there. And they extract that information from there and distribute it to the respective states. And then you have entire, it is passing on. So what you are saying, that is 100% correct. Ki we need to have a decision support system, special decision support system. But uske liye again, we need range boundaries, we need division key boundaries, so that you actually know ki this is falling within my administrative unit, a DFO, and the subsequent ranges, so that range officer or jo bhi lower staff hai, that could become. Unfortunately, we don't have those boundaries, protected areas ki ya iski. So we need to generate those kind of boundaries. This is point number one. जो second जो आपका aspect है, looking at loss, I would urge कि जैसे I have seen नागपुर में आप लोगों का जो remote sensing हो सकता है, it is a nice infrastructure. Last time when we were there, we visited that place. So we should have somebody कि जैसे ही fire report हुआ तो उसी समय का Lancet का data ले, and there is a very clear cut algorithm which could be converted into a tool कि data डालो और वो burnt area map करके दे दे. So that the officer who has actually traveled so long, before traveling could have seen कि burnt area में कितना hectare area आ रहा है. Then use a decision कि मुझे जाना चाहिए या how can I. So see, things are available, but somewhere we need to create some of the supplementary data sets which can strengthen it, and some of the tools, those could be embedded. So that is by design what we always propagate कि ऐसा होना चाहिए. At some point of time, I believe probably 2005 में NRSC में Forestry Division ने they have developed a semi-decision support system. They call it INFRIS, INFRIS, Infrared Forest Resource Information System, for probably Andhra Pradesh and one of another state in the peninsular India. They demonstrated it. But pan India, maybe सारी administrative boundaries जो forest की हैं वो अवेलेबल नहीं हैं, और हर किसी के पास उस तरह का मैन पावर नहीं है कि जो डेटा को ऑलमोस्ट रियल टाइम वो कर ले. तो कहीं ना कहीं वी नीड टू स्ट्रेंथन इस तरह का. सम ऑफिसर्स दे कम विथ अ वेरी मोटिवेटेड काइंड ऑफ एस्पिरेशंस कि मैं रिमोट सेंसिंग जीआईएस में ऐसा कर सकता हूँ, बट यू अंडरस्टैंड द स्कीम ऑफ थिंग्स वेरी वेल. सो दे गेट प्रिटी डिसेंट टाइम फॉर अ ईयर और टू and then they are somewhere else. So we need to bring some dedicated manpower towards this. So there are plenty of options which should be operationalized so that such traveling, such interpretations or uncertainties which are there, those could be minimized. So I to look at you guys only कि आप लोगों को कहीं ना कहीं हम लोग सिर्फ hand holding कर सकते हैं या बता सकते हैं कि ऐसे होगा. So system has to develop these kind of mechanism कि कैसे use करें. Possibilities are there, 101%, well tested, even tested in the times. So those all things are there, but we need to adapt and bring those in the operational level. That is there. I hope I am correct in all ways in replying this. Yeah.
Thank you, sir. Any more questions? Please. Mic.
Good afternoon, sir. Sir, since the morning sessions, I have been listening about rate of variation in the carbon sequestration according to the age of a tree or the maturity of the plantation. Sir, I would like to know about that more. And do we have any mechanism for calculating that?
To be very honest, I don't know the correct answer. Okay, that is for sure. But just to supplement based on my best of the readings, we know estimates for some of the age groups for some of the forest types and in the broader forest types. Like अगर आप अभी Google करें तो you will get some of the publications which have estimated for temperate forest, tropical forest, tropical dry forest, these kind of things with respect to age, what kind of carbon sequestration potential is there. But systematic numbers are absent. One of a fundamental reason for this is such kind of estimates, they need long-term ecological plots. or monitoring, LTMs we call it, long-term ecological monitoring plots. Unfortunately, when you see the map of long-term ecological monitoring plot, India में कहीं नहीं है. ISC ने अभी कुछ शुरू किया है, they have put 1 or 2 plots, और हल्द्वानी के पास एक फ्लक्स स्टार इंस्टॉल हुआ है, वहाँ पे एक प्लॉट बना है. So that is the reason we don't have actual numbers. So somewhere we need to bring such type of mechanism. It's just not for academic research, it is very much useful for forestry, kind of discipline, or then forest management. So जो numbers हमें मिलते हैं, हमें global जो journalized numbers हैं, वहीं से मिल रहे हैं, and we are just trying to understand those.
Okay, okay. Thank you, sir.
All of you must have visited or stayed at Bhima Shankar guest house at some point of time. The hill of Bhima Shankar forest, there are 2 monitoring plots established in 1935. Then in Mahabaleshwar, you have similar plots established in 1935. And I had an opportunity to do the analysis in, that was around 1995. We published a paper with Smithsonian, and from 1935 to 1995, we looked at the turnover in the biomass, and we looked at turnover in the species. And apparently there was a network of plots. Those were established in many places in India between the 1930s to 40s by Britishers. In my personal experience, I am telling you, because I have seen those files and used that data, till 85, very regular basis, or every 5-year interval, readings were taken. Even today, if you go to Bhima Shankar, those areas, you will find many trees with numbers nailed on them. Over a period, those number plates have been encircled by the tree growth. But as Dr. Joshi was mentioning, in India today we have very limited such exercises. One exercise that is conducted by Indian Institute of Science, Bangalore, they have in Madhumalai 50-hectare forest plot that is monitored, and that is one of the plots. There are 9 such plots across the world. Number might have increased now. That exercise is coordinated by Smithsonian Institution, and where this tree dynamics, as you are talking about how every species grows at what rate in what condition. So whatever given and what kind of species diversity gets performed. So these information are more serious research kinds of information, and we have limited expertise as well as infrastructure for that. In World Bank project, while Mr. Gokte was handling that, in some of the wildlife sanctuaries in Maharashtra, that time I was working in Fansad Wildlife Sanctuary, so I can very much vouch that on similar lines forest plots were established, but probably the data collection and then maintenance of those plots was not continued. So that was also around late 1995-96. So today if we would have maintained that data, then we would have got at least 20-25 year data to understand what kind of species variation as well as biomass variation that would have taken place for those patches. So it requires a very consistent approach and also more will to do that.
Okay, thank you, sir.
I would like to react to the question that she has specifically asked for the rate of carbon sequestration when the trees are younger. Actually, carbon sequestration is a function of biomass. So when the trees are younger, they grow at a higher rate. The rate of photosynthesis is higher. If you do the stem analysis or the stump analysis, you will find that the rings are wider when the trees are younger. When they grow mature, then they don't put on increment to that extent. Means carbon sequestration is a function of biomass or the volume, and the volume growth is lesser when the trees mature. It automatically we can infer that rate of carbon sequestration is higher when the trees are younger or in the youth. Thank you.
Now I think all the questions have been exhausted. So I would like to thank sir for a very lucid explanation of remote sensing and its application in carbon stocking. The presentation was so colorful and so good, sir. So I think the post-lunch session was comparatively very interesting, and it kept everybody awake and interested in the presentation and your delivery both. Thank you so much, sir. You made it look very easy, but the actual thing is, until and unless we do some hands-on, we are not going to get hold of it. So out of curiosity, out of some curiosity of gaining more knowledge and trying it out, let's try all the free things that you had explained in your presentation. Thank you so much, sir. Thanks a lot. This was the last session for the day, and we conclude with a few announcements to be made. First of all, I apologize for today for making you sit in the auditorium with little bit of temperatures being on the higher ends. It was first-hand experience of greenhouse gas effect that we had in the afternoon. Tomorrow's sessions will be carried out in the Training Building 1, Siddhant Hall, which is just opposite to this building, across the open-air auditorium. Another announcement is about the compendiums that were released in the afternoon. People who want the compendium, they just have to give their names. Don't ask for it immediately. We'll be giving it to you when you will be leaving this place. So at the registration counter, you may give your names, and then we'll be distributing the compendiums accordingly. The third and the last announcement is about today's dinner, which is also going to be gala dinner in the amphitheater just across the building. The program starts at 7:30, so I request all of you to be there in the evening and enjoy the entire milieu that is going to be there. So with this, we conclude today's sessions. Thank you so much. Thanks a lot.